Hello students, welcome. Previously, lesson 2, form 2, topic 2, we were dealing with physical properties of alkali metals. We have done the first one, that's the softness and ease of cutting of alkali metals. So today, lesson 3, we want to do the melting and the boiling points of alkali metals. We want to do the fast ionization energy of alkali metals and the electrical conductivity of alkali metals. So the alkali metals have relatively low melting and boiling points. To see as a trend, we are told the melting point and the melting and boiling points of alkali metals decreases down the group. If we see the table that we were using previously, we are having here melting point, here boiling point. If you see, it is going to decrease down the group from lithium to potassium. So the trend will be the melting and the boiling points of alkali metals decreases down the group. So what is the reason? This is due to the decrease in the strength of the force of attraction holding the atoms together as the atomic size or as the atomic radius increase down the group. So during the exam you can be told, explain the trend in the melting and boiling points of alkali metals. So the answer will be the melting and the boiling points of alkali metals decreases down the group. Reason? This is due to the decrease in the strength of the force of attraction holding the atoms of alkali metals together as the size or as the atomic radius is increasing down the group or increase down the group. So example, in comparing the melting and the boiling point of two alkali metals, here we are told sodium has a higher melting point than potassium. That's very true because when you see the table, sodium is having a melting point of 98 and potassium is having a melting point of 64. So that means we're saying sodium has a higher melting point than potassium. Reason? This is because atoms of sodium are small. So if they are small, hence are held together by strong force of attraction between the atoms of potassium. Between the atoms, then potassium, which are large, hence held by weak forces of attraction between atoms. And we are told melting involves heating of this force of attraction. So second or next, number 3, we are going to do ionization energy or the fast ionization energy. So what is ionization energy? During the exam you can be told what is meant by the term ionization energy. So ionization energy is the minimum amount of energy or the minimum energy required. The minimum energy required to remove an electron from the outermost energy level of an atom in the gaseous state. So remember, alkali metals are having only one electron in their outermost energy level, hence they have only fast ionization energy. So if an element is having 2 electrons in its outermost energy level, it will have fast ionization energy and as well as second ionization energy. So let's see now the trend in the ionization energy or in the fast ionization energy of alkali metals. So here we're having the fast ionization energy of alkali metals decreases down the group. Reason? This is due to the decrease in the strength of the force of attraction holding the atoms together as the atomic size or as the atomic radius increase down the group. That means you give the same reason when you're dealing with the trend of the melting and the boiling points and that side of ionization energy. Because ionization energy will decrease when the atomic size or the atomic radius increases down the group. So to see, comparing the fast ionization energy of two alkali metals, we are told the fast ionization energy of lithium is higher than the fast ionization energy of sodium. This is because lithium has a smaller size or has a smaller atomic radius, hence has stronger forces of attraction holding its atoms together. Then sodium, which has large size or large atomic size, hence has a weaker force of attraction holding its atoms together. So finally, number 4, we are dealing with electrical conductivity of alkali metals. So we are told conductivity in metals is due to the presence of delocalized electron in the structure of the metal. Alkali metals are good conductors of heat and electricity, and the reason is this is due to the presence of delocalized electron in their structure. So we are told electrical conductivity of metals increases with increase in the number of delocalized electrons. And you know, all members of alkali metals have one electron in their outermost energy level. Hence, they have similar conductivity, or they have the same electrical conductivity. So during the exam, if you are told compare the electrical conductivity of lithium and sodium, there's no comparison there because they have the same electron, or they have the same number of electrons in their outermost energy level. That means they're going to have the same electrical conductivity or similar electrical conductivity. That's the end of our video.